stage 2, that's stepped off this one.
Okay, so it's where it drops is what stage, what like
Yeah.
feet, yeah, okay, what line?
I mean, that's because I'm going from this side to this side. I could just easily go bottom to top and then it'd just be the reverse.
If you had one stage at the bottom, then that drop line is where you're going to find your next speed. Yeah.
Yes. And yeah, if this was like a guess and check problem, that'd be close.
But if you had a condenser, you would go one more.
A boiler, yeah. Oh yeah, that's true. So I'd have to do one more after that.
Okay.
Do you have those how much do you find this over the operating line?
Same kind of thing. You just calculate your L and your D, and then.
How? Like, if there's just no column and insulation of it, it's not changing? How?
It is changing because you're introducing feeds.
Okay.
Anytime you introduce a feed, you're throwing off your mass balance. So you have to redo your operating mode. Jared?
Would there ever be a situation where you would put saturated liquid in the top and saturated vapor in the bottom, and like two feeds, and like would those interfere with each other? Like would
No, that'd be the same thing. So you
It's the
could
same
do that
thing.
instead of a reflux.
Okay.
Matter of fact, that's called like a stripping column if you just feed liquid on the top, and then that's for like dilute solutions or things like that.
You can do an example of that with
Bottom line would be.
Well, no, it'd just be instead of a reflux, you just have a feed now. And then you'd only have one operating line because there'd be nothing entering in the middle of it.
So you have two feet?
Oh, you mean one on the top, one on the bottom?
Yeah, the one top, big on the bottom.
Yeah, I don't. That'll-
Can you explain what this statement means? A total condenser is used which returns saturated liquid reflux at a rate of 1 1/4 its least value.
Yeah, so I talked about the R min last time, right? So that's the point. So remember, R over R plus 1, if you drop your reflux ratio, that makes the line go like this.
Okay.
And it shallows out. So at a certain point, if you go so shallow that you intersect over here, there's no way you can ever get to this point.
Okay, so we're assuming from that point it's 1 1/4, like yeah, okay.
So you'd find your R min,
Yeah.
multiply that by 1.25. That'll give you a new R min, which is now steeper, and then you can get that.
So it's our thing. You just find what that slope is,
Yes.
and then you solve that one.
Yeah, you have to find your slope, solve for R min. Sorry, what? Because that's what the problem said. It's the reflux rate is 1.14 times its least value. So 1 1/4 times.
I have a question about the lines, the slopes for the lines with the different stages here you're talking about. Are those R values or are those the slope values for the lines? Because they're less than 1, right? If you did
Yeah, those are the R values, not the slope values.
Okay. Because with these what's coming back in and what's going on that stage.
It's what's leaving in liquid over what's leaving in vapor.
Okay.
I think. I've worked that out. That there's a possibility that may be wrong.
Can you just go over how do you find one day, how you actually solve it?
Yeah, so you would have some kind of guess for XB, and you'd have some kind of guess for XD, or you'd know what XD is. So wherever the feed line is, I'll draw a new one.
And then you can also solve
He's just going over. Oh, he's going over.
So say your feed line, let's say it's in the middle, for sake of argument. So wherever that intersects the equilibrium line, that will let you draw this line. Now the slope of this is your R min. I just, for sake of argument, just to switch it up, make it interesting. Wherever the feed line intersects the equilibrium curve. Because if I step here, I can step infinity times down here, and I never get there. So anything less than that reflux, you're stuck there for eternity.
So with 2 feet going in, the arm will change based off the process or?
Yeah, the top feed.
So what I'm trying to get is, there's gonna be 2 feet.
Yeah, whichever one is closest, because you have to make it past the first pinch. That's what that's called, is a pinch point, whenever you get really low.
Boil up rate is
Yes, I believe so. 90% sure. Check over and notes and Google it.
What happens when the 2 feet are mixed on accident?
They're mixed.
By mistake, the 2 feeds are mixed. This is the same one that we're just doing. Are mixed at the topmost of the 2 feed plates specified in your stuff. What recovery impurity preventing the overhead defect. So you just add the feed.
Wait, they're mixed or they're switched?
They're mixed and put it at the top.
Oh, well then, yeah, there's only 1 feed.
So you just.
You combine and have like.
They're still just both saturated. What do you do with the purities when you add?
Do a material balance.
I just thought they would be like 43% as a feed, like benzene.
You're just saying it would be an average.
I think so.
You should average the 2 purities of the strings that you
Well, you wouldn't average, you'd do a balance. If they're equal if they're each the same amount, then yes, you average.
Oh, so like 0.5 times 100 equals.
Yeah, it's like
Okay.
it's this calculation. Same thing, 2 things.
Oh, okay. Okay.
I'm sorry, are we talking about the same, was this the question? I'm sorry, I was trying to catch in on the end part. So would it, like it's saying that you feed it, like it was saying that like 2 streams got mixed and you're feeding them at the top 2 stages. So there's 2 streams going in?
No,
They're the
just
same?
1 stream, 1 feed.
Okay, so it's now just 1 feed. So what does it mean when it says they're introduced at the topmost of the 2 feed plates specified in the design?
Wherever you figured out your top feed.
Yeah, so if
So
one
it doesn't-
feed is like the 3rd, the other one is like the 10th, you do the 3rd.
Oh,
Whichever
okay,
is the
all
top
right.
out of the-
Got it.
Okay, now if the feeds were reversed.
Then it's a 2 feed wrong again.
Oh, okay, so it's just, okay.
Any other terms on the homework that you're not sure about? There's a term we haven't discussed that would behoove you to study before Wednesday.
Azeotropic?
What term is it?
Huh?
What term is it?
I'm not going to tell you that part. I'm telling you there's a term out there.
Is it on the home?
I'm pretty sure, yeah.
Wait, there's a term in the question.
There's some kind of term that I know he's talked about in class before. And when he talked about it, I'm fairly certain a lot of you were sleeping.
Was it today or the time before?
No, this was like weeks ago. But it's on the homework, I'm pretty sure.
And it's
And we haven't
sometime-
talked about it at all.
What letter does it start with?
It's before.
Yeah, give us-
Let's do charades to figure it out.
Yes.
Yeah, let's wrap it.
We haven't talked about it at all today.
Not today, huh?
Can you tell us a day?
I don't remember the day. It was a Wednesday because I was here.
So not the Wednesday, but the Wednesday before.
We talked about it last week.
Well, yeah, maybe.
So 2 Wednesdays ago.
Yes.
Is it?
What was that name?
plate efficiency?
Oh.
No.
What was it?
Plate efficiency.
Plate efficiency.
Plate efficiency, oh, plate efficiency. But not plate efficiency. But I have no idea what that is.
So would that be like how much is condensed or something?
No, that just means, so remember, one of the central assumptions we made over here was that all the stages are equilibrium stages. And that allowed us to say that each stage hits the equilibrium curve.
So this is like not assuming equal overflow.
Okay.
No, you still assume equal overflow. You just assume that you don't, it's not equilibrium, so you never hit the equilibrium stage. The equilibrium curve.
Okay, so it's like 75%, you just like
75% of the way.
75% of the way?
That's it.
What?
75%, no, you're down. 75% down. There's a formula too that he works out that you can do if you're analytical like that.
What's the formula?
It's got something to do with Y stars and Ys and shit.
Oh yeah, I remember the Y star.
I take it you're not analytical in that way.
No.
Talking about.
Yeah.
He did talk about it.
Solving for the efficiency would be hard. Well, last time this was just see,
When you said 75% efficiency, that means you use 75% of the way?
yeah, so whichever, so it's kind of like the lever rule thing. If this whole line is 1, 75% is just 3/4 of that.
Yeah, you could just do that.
What you could also do is draw like a pseudo-equilibrium curve, where you just draw a whole curve that's 75% of the actual
Oh,
curve.
that would be really hard.
Measure.
So yeah, you take a few points. So like go to point 1, and you'd measure the distance of this line, and then just go 75%, and then do that all the way up.
Oh, wait.
And then just trace like a dotted line, making the curve.
Couldn't you just do like y equals 2x and then just that times 0.75 and then get the points off of that? Would that work? Because then, right?
What? That might work.
It's like
Maybe. Yeah, no, that wouldn't work. You can't multiply it. You can't multiply it by 1.
what did
There's probably something you can do to that.
You could probably do 75% of like probably or something half the stage.
You could use it as a rough estimate, which is just figure.
That's really hard.
That's all you have to do is
Huh?
You can use it as a rough
substitute
estimate.
and hit the call. Text that shit.
What I said?
So is this the thing where it uses latent heat?
No.
I mean, that'll be a good first guess.
Nothing
Why
to do.
would- like,
Well, when I worked on, say 75% of your answer.
Because
Because
the only thing you went over was
no,
star
when you're doing
curve, like
alpha
L
equals
star.
y equals 2x divided by
Stars usually mean on the equilibrium
or
curve.
x plus 1.
It's where efficiency equals y minus y sub minus
That sounds right. That
y
sounds
star
right.
minus y star.
If you'd like to tell me what that is, so I'll draw on it.
Yeah, it's efficient, or epsilon, whatever,
probably good.
equals y sub I
No, I think you want to do 0.75 on
minus
both.
y sub I minus 1. Like, it's I minus 1 to the sub over y star sub I minus the same thing star. Star, no, it's star. What is that, star?
All right, what does that mean? Is the question.
That's like the stages, I
It's
think.
not star.
Oh, stars, right?
It was like a real quick thing. I mean, he told us, he like said everything once and then like moved on.
Okay, so what that means, this will be, say this is y star I minus 1. That means that's the equilibrium. Equilibrium stuff.
100% efficiency.
Yeah, star means 100% efficiency at equilibrium.
And I is the stage number?
I is the stage number, so I minus 1 is the one below. So below, you're coming to the top. This is y star I. right? So y star I minus y star I minus 1 is the length of this line, right? Cool. yi, that's the thing that's somewhere here in the middle. So it's like normalizing. So if this is 1, your efficiency will be 75% or whatever it is. It makes your separation less efficient.
Yeah, which is always true.
The y star is at a point not on the equilibrium?
No, y star is on the equilibrium curve.
Okay.
Y star is up here, y star I minus 1 is there. And then this is y I minus 1, and then yi would be somewhere along this line. So yi is the actual y that's in equilibrium with the x.
So that's the formula, but if he tells us it's 75%, then like literally it's the same thing. We just
Yeah.
like measure. We have to
Yeah.
measure it no matter what.
Yeah. Right.
I mean, unless he told us, like I don't know what else he could tell us. Like he would be like your y star. Like how else would he word that besides saying your efficiency is the
Right. It would.
Would the plate efficiency affect flow?
That's what he does.
No.
He does it all the time.
It just affects equilibrium. So it just affects the compositions. It says, does that affect the flows? And no, equal mole overflow is always, it's still, yeah, only changes composition.
And like the number of stages, what you're trying to.
Oh yeah, definitely. Yeah. So you need more stages in general because your separation is what's the
But for now, we should still be sticking with equal mole overflow for the most part.
Yeah.
I'm not worried about not having a competition.
Anything with that is not.
Which is also what you have to draw.
But Sean's
Maybe
picture.
lecture on one.
You all have a big advantage over the people that weren't here, so you can share it with them if you'd like.
No, I'm just kidding. A lot of people are talking about it.
As of
I think like minus 20 points though. You let you down? Why? Dude, you haven't even gone.